Elon Musk has finally spoken out about the three ISATs, and his warning about a possible collision path is rippling through the scientific world and igniting social media across the globe. In a string of posts that spread rapidly, Musk, who has access to SpaceX's sophisticated tracking infrastructure and direct lines of communication with NASA, disclosed something the agency has not openly confirmed. Atlas's trajectory has shifted. Based on Musk's analysis using SpaceX tracking data, the enigmatic interstellar object is no longer on a harmless flyby course. It is now following a path that brings it dangerously close to Earth's orbital lane, with a potential collision window opening in roughly 28 days. Musk was direct. The chance of impact is not zero, and it is rising. NASA is aware of this. They are withholding the information to prevent panic, but people have the right to understand what may be approaching. He followed these claims with SpaceX tracking visuals showing Atlas executing systematic course changes that have redirected its path by millions of miles, adjustments that have steadily drawn it closer to a direct encounter with Earth. What makes Musk's warning especially unsettling is that he is not merely sounding an alarm. He has announced that SpaceX is already working on emergency response strategies, including possible missions to modify Atlas's trajectory or deploy defensive systems. When someone whose career is literally building spacecraft begins discussing planetary defense in real time, it demands attention. Before we break down Musk's trajectory analysis and explore why NASA refuses to confirm his claims, hit subscribe and smash like, because what you are about to learn about Atlas's collision course could completely reshape how you view the next 4 weeks. Musk has been labeled alarmist in the past, but when he is issuing collision warnings grounded in his own tracking data and supported by SpaceX engineers, dismissing it as hype may be a mistake. Let's look closely at what Elon Musk revealed about Atlas's trajectory, because the details are precise and deeply disturbing. According to information Musk shared from SpaceX's tracking network, Atlas has executed 23 distinct course corrections over the past 6 weeks. Each maneuver involved minor velocity changes of a few hundred miles per hour and trajectory shifts of only a few degrees. Yet taken together, these adjustments have shifted Atlas from a safe flyby route to one that intersects Earth's orbital zone. Musk posted detailed orbital mechanics calculations showing that Atlas's original trajectory would have carried it past Earth at a distance of about 8 million miles, far outside any collision danger. But the combined effect of those 23 maneuvers has reduced the closest approach to roughly 180,000 miles, closer than the Moon. A SpaceX engineer involved in the trajectory analysis explained why this is alarming. When you observe systematic corrections that consistently shrink the closest approach distance, that is not random navigation. That is targeting behavior. Atlas appears to be steering itself toward Earth using deliberate, calculated maneuvers. The open question is whether it intends to pass by 180,000 miles or whether further adjustments will bring it even closer. Musk's warning, however, goes beyond proximity alone. He pointed to a specific window 28 days from his initial alert when Atlas's projected position intersects Earth's orbital path. If current trajectory trends continue and additional velocity changes occur, Atlas could place itself directly in Earth's path with timing that suggests intentional interception. SpaceX tracking indicates that Atlas is accelerating at carefully chosen intervals to maximize gravitational assist from planetary alignments. This is advanced orbital mechanics, using planetary gravity to reshape trajectory while conserving fuel, exactly the kind of planning used by spacecraft mission designers plotting efficient paths through the solar system. Musk underscored the precision involved. Atlas understands orbital mechanics better than we do. Every adjustment is perfectly timed to alter its course with maximum efficiency. This is not a comet drifting on inertia. This is a craft executing a complex navigation sequence, and that sequence is aimed at Earth. Musk also disclosed something SpaceX detected that NASA has not publicly discussed. Atlas's velocity relative to Earth is decreasing. Normally, objects on hyperbolic flyby trajectories speed up as they approach a planet and slow as they depart. Atlas, however, is showing velocity reductions that imply active braking, as though it is preparing to match Earth's orbital speed instead of streaking past at interstellar velocities. Musk's analysis included probability estimates that sparked intense controversy. He calculated a 12% chance of actual impact with Earth based on the current trajectory and observed maneuvering behavior. While 12% may sound small, in planetary defense terms, any probability above 1% is considered extremely serious. For comparison, asteroid Apophis briefly carried a 2.7% impact probability in 2004, and that alone triggered global attention and emergency tracking measures. At 12%, Atlas represents a threat level roughly 4 times more severe. Yet NASA has not initiated visible emergency response actions. Musk did more than issue a warning. He announced that SpaceX is already developing response options, and the scale of those proposals highlights both the gravity of the threat and the limits of our defensive abilities. SpaceX has reportedly been outlining mission concepts for rapidly deployable spacecraft that could rendezvous with Atlas and attempt to alter its course. Musk released early designs showing modified Starship vehicles outfitted for either kinetic impact or close proximity nuclear detonation, the two primary methods considered for deflecting incoming objects. The kinetic impact strategy involves crashing a spacecraft into Atlas at extreme speed to change its momentum. NASA successfully tested this method with the DART mission. But Atlas presents challenges that DART's target did not. It is much larger, it is moving faster, and most importantly, it is maneuvering. Striking a stationary asteroid is difficult. Striking an object that can actively dodge is exponentially more challenging. A SpaceX mission planner involved in the conceptual work described the problem. We are essentially trying to design a mission to intercept and deflect something with superior propulsion and maneuverability. It's like attempting to ram a fighter jet with a slower aircraft. Even if we approach, Atlas could simply accelerate or alter course to evade impact. The nuclear option, detonating a warhead near Atlas to vaporize surface material and generate thrust that pushes it off course, appears more promising but comes with serious complications. First, it would require international approval to launch nuclear weapons into space, violating multiple existing treaties. Second, we do not know Atlas's composition or how it would respond to a nearby nuclear detonation. Musk addressed these issues bluntly. Treaties are designed for normal situations. This is not normal. If an object is on a collision course with Earth, we use every tool available, treaties or not. Violating space weapons agreements is preferable to watching a city be destroyed because of bureaucratic hesitation. The most revolutionary part of Musk's proposal involves deploying multiple Starship spacecraft as a gravity tractor, positioning them near Atlas, and using their combined gravitational pull to gradually shift its trajectory over time. This is the gentlest deflection method, but requires weeks and assumes Atlas does not resist or counteract the gravitational influence. SpaceX has reportedly completed preliminary planning showing that the first trajectory modification mission could launch within 12 to 14 days if approval is granted. That speed is remarkable, made possible by Starship's rapid reusability and SpaceX's launch infrastructure. Still, a 12 to 14-day launch window leaves little margin within Musk's 28-day collision timeline. There is, however, a darker interpretation of SpaceX's rapid response planning. Some analysts argue Musk is leveraging the Atlas situation to push his Mars colonization agenda by highlighting humanity's vulnerability and the need for backup planetary settlements. Whether his warnings stem purely from planetary defense concerns or also serve strategic business interests remains contested. Musk's public statements have ignited controversy with NASA, exposing deep tensions between commercial space companies and traditional government agencies over who controls information during potential crises. NASA's official response to Musk's trajectory warnings has been carefully phrased and notably restrained. NASA states that it continues to monitor Object 3/Atlas using multiple tracking assets, that current trajectory assessments do not indicate an imminent collision threat, and that caution should be exercised regarding predictions from non-peer-reviewed sources. This diplomatic language essentially translates to a belief that Musk is wrong and stirring unnecessary fear. Yet notice what NASA does not say. They do not release their own trajectory data. They do not explain why SpaceX's calculations would be flawed. They do not address the specific course corrections Musk highlighted. Their response dismisses without substantiating. A former NASA administrator explained the agency's predicament. NASA cannot openly contradict Musk without revealing classified tracking data that might validate some of his concerns. Instead, they reassure the public and hope Musk retreats or attention shifts elsewhere. But Musk has not retreated. He has escalated, releasing increasingly detailed tracking information and challenging NASA to publish their trajectory models. He frames the issue as one of transparency, arguing the public deserves to know about potential threats, even if that knowledge causes unease. The standoff raises a fundamental question about crisis communication. Who decides what the public should be told? NASA maintains that premature warnings based on incomplete data can cause more harm than good. Musk counters that keeping people uninformed until it's too late to act is unethical and potentially disastrous. Space scientists are sharply divided. Some side with NASA's caution, pointing out Musk's history of dramatic statements and noting that while SpaceX's tracking is advanced, it does not match the scope of NASA's global network. One planetary scientist argued Musk is extrapolating from limited observation windows and that NASA's broader dataset may not support the same conclusions. He is not an astronomer or a planetary defense specialist, they note, but an engineer and businessman who may be out of his depth predicting complex trajectories. Others defend Musk's decision to share his analysis. They argue that SpaceX's tracking capabilities are genuinely sophisticated, that multiple independent assessments strengthen understanding, and that history shows governments often downplay risks to avoid panic until danger becomes undeniable. A space policy researcher described the broader implications. We are witnessing a historic shift in who controls information about space threats. For decades, government agencies monopolized tracking and risk assessment. Now private companies like SpaceX possess equal or sometimes superior capabilities. The old centralized model of information control is eroding, whether NASA approves or not. To judge whether Musk's warnings are justified or exaggerated, we must examine what multiple tracking sources are observing about Atlas's trajectory. Independent observatories around the world have confirmed that Atlas is making course corrections. The existence of these maneuvers is not disputed. Even NASA's carefully phrased statements acknowledge orbital variations. The disagreement centers on what those changes mean for collision risk. SpaceX data shows 23 corrections over 6 weeks, each reducing the closest approach distance. Independent university observatories have verified at least 18 of these, with others possibly too subtle to detect without SpaceX's sensor resolution. Musk's core claim that Atlas is steering closer to Earth appears factually supported by observable evidence. However, predicting trajectories becomes exponentially more difficult when the object has propulsion and can actively change course. NASA's reluctance to provide firm projections may reflect genuine uncertainty rather than concealment. Forecasting Atlas's position 28 days out requires assumptions about future maneuvers, and those assumptions may be impossible to make reliably. An orbital mechanics specialist explained the challenge. With asteroids, trajectories are governed by gravity and momentum, predictable forces. With Atlas, we must guess what it will choose to do next. If it maintains current behavior, Musk's collision scenario is plausible. If it alters behavior, the prediction collapses. NASA's caution may stem from that uncertainty. What multiple tracking sources agree on is this. Atlas is currently on a path that brings it within lunar orbital distance, closer to Earth than the Moon. Whether it passes safely at that range or makes further adjustments that bring it closer or even results in impact depends on decisions Atlas makes that we cannot predict. Musk's 12% collision estimate may be defensible if Atlas continues its present behavior, but that is a major assumption. We are effectively betting that an object capable of maneuvering toward Earth will not also maneuver away, which seems unlikely unless collision is intentional. This creates a paradox. If Atlas has enough propulsion to steer toward Earth, it also has enough propulsion to steer away. So unless impact is deliberate, an attack or experiment, why would it place itself so close without executing final avoidance maneuvers? That paradox is why some scientists dismiss Musk's warnings outright. Why would an advanced interstellar object accidentally crash into Earth due to navigation errors? It makes little sense. Either Atlas is not actually on a collision course, aligning with NASA's stance, or any apparent collision trajectory is deliberate and cannot be predicted without understanding Atlas's intentions, a deeply unsettling middle ground.